So yeah, I'm going to get started. And so yeah, my name's Scott, and I'd love to talk to you today about what's Q or what's new in Android security. I care passionately about app security, and like many of you in the room, kind of probably spend a lot of our time focusing on feature development, day-to-day app development. And whilst no one ever says they don't care about security, I tend to find that it's never like high enough priority. We're too busy working on functional requirements, visual niceties, rewriting things in Kotlin. This conference, there's tons of talks on things you can do, re-architecting your app, modularization, and there's not enough time for all the things. And the idea of this talk really then is to sort of focus on those security things that we can, add to our app from the new APIs in Android Q. But actually, as I went through it and sort of researched this talk and started putting it together, I actually realized that there's actually more focus on breaking changes. Android has traditionally been more open, and these enhanced privacy and security features of the later versions of Android are actually producing more issues for us developers, and this lockdown of things makes it more work for us. So briefly, what we're going to cover these three areas, I figured to start with updatability, and building on something from a previous release of Android. Just wanted to sort of do a quick recap on Project Treble, just to show how that's going and to what's sort of next. So Treble was part of Android O. It really introduced this whole idea of a vendor interface, and this was the kind of a gap between the Android platform and then the vendor subsystem. So their implementation, drivers, and things like that. And what we've seen, since O, is that to show this is working. Sorry, the idea of this was to get, system updates would be easier to apply, less testing for OEMs and vendors to do. And what we saw is evidence that this is working. As we can see, Android P, when that came out for the preview, the developer preview versions, there were 8 devices that supported that from 7 device makers. Previous to that, it was just the Pixel or the Nexus devices. That was the only ones you could use for that. And then so if we see Android Q, and we see 23 devices and from 13 device makers, and we'll see that sort of go up. So there's good evidence this is working. And also, if you on the Google blog article which talks about this, talks about the adoption of P over Q has been times 2x. So we can see that it's getting easier and easier for manufacturers to put updates. And I mention this because often when a new feature or a breaking change comes out on Android, we often have a good lead time on that before majority of users are using it. Typically, it's a year before you have to really worry about those changes before a good portion of your users are using it. But what I'm saying here is that's getting less and less, which is great for us users, but for us developers, we need to sort of be aware of those changes. The next kind of Treble 2.0 is Project Mainline. And this is kind of, the idea here is to split Android into smaller sort of components, which are independently updatable. So you don't need a full system update. The key kind of benefit here is getting security updates, monthly patches quicker. And this is, these will be delivered via Google Play. And there's a ton of components, but I sort of pick out the 2 kind of security-minded ones with a media framework. If anyone remembers stage fright from a few years back, it's often an area of exploits. So it's good that now that is potentially updatable without needing a full system update. Same with Conscript, which for the SSL engine and encryption and stuff like that. So I mention these things just because it's kind of about the platform getting more secure and being more updatable. But the real kind of crux of this talk is on is on the privacy part. And Chet thankfully covered a couple of these glimpses of these earlier, so it just builds on that from earlier. And over the last couple of versions of Android, there's been actually quite a lot of security stuff to talk about. I've done this kind of what's new in security talk like 4 years in a row, because there's just stuff every year to sort of talk about. But this year, more so, more focus on the privacy side, which is great from a user point of view, but potentially more work for us as developers. I thought I'd start in this kind of privacy section talking about location, because when we talk about user privacy, location is up there as one of the most important things. And as Chet kind of alluded to this morning, Android Q is essentially giving users more control and more visibility about your app's access to certain data and personal information. If you access location in the foreground on Android Q, very little has changed. It's a runtime permission. You need to code defensively. Check if you've got that permission. No big change. The real change is in the background, and so the background location restriction is always enabled in Android Q, and you'll see there's a slightly changed permission dialog. It's now like a tri-state one, so you can allow only when the app is active, or the default used to be all the time. And if users do allow all the time, they'll get a reminder from the system to say, hey, do you know this app has access to your location in the background? And then users from that can just revoke straight from that notification. And so the advice is like with any kind of runtime permission, is to gracefully degrade, handle this whole being denied, and don't ask again. And really, you need to be in your apps. If you need background location, you need to make sure that you're providing that value to the user. Your screen before you ask for that permission needs to be very clear on what you need and why you need it, and the fact that the app isn't going to work without it. So this will affect some apps, not others. But if you need background location, it's big changes. So as part of this, there's a new permission. So this it's a pretty big deal, being a new permission. If you're targeting Q as your target API level, you need to define this in your manifest. If your app is targeting P or lower, and you have the other location permissions, your app will get this at runtime automatically. So I think this is a good kind of like signal or good evidence that Google do. This is a big change, but they do actually care about backwards compatibility. However, there are a couple of cases around where if you're on a device, with Android P device that's upgraded to Q, you need to be aware of. I've just put this just to show you the table, but I'd recommend visiting this link. I'll post the slides afterwards. But if you're using location in the background, I highly recommend going through this table and making sure there's a couple of cases you'll need to sort of handle. That's worth checking out. And it may be a headache for some of us. And the last thing on location, if you're using like a foreground service to sort of maintain location, foreground service is now like there's a permission around that. It's not a dangerous permission, so you don't have to sort of ask the user to approve it. But you do need to define it. And there's something in Q that's new, is a foreground service type. And there's like a set number of use cases. There's a general feeling anyway that foreground services are kind of being restricted, like with the new permission and the types. So location is a legit kind of use case for this, so that's why it's got a type. But I just mentioned that because that's something you'll need to add as you target Q. So that was kind of location changes. And one of the other areas of kind of external kind of access, external storage, which is undergone changes, and Chet said this morning that it got a bunch of feedback, and they've changed the way it works a bit. And it's kind of a bit overdue, this, because the SD card is a bit, used to be a bit like the Wild West, really. You had to, anything you wrote to the SD card or external storage, you couldn't necessarily trust that when you read it back in. It could have been tampered with by an attacker, by another app. So this restriction is, welcome and overdue. But there's a bunch of changes here which, if you need to access the external storage, are going to be big changes for some of us. And the big thing is it's a filtered view. It's called scope storage. But if you're accessing files created from other applications, you're going to need to use the media store to access those files. And you kind of might guess from the name that it's only certain types of files. So it's really built for supporting photos, videos, music. And it's worth noting, actually, you only need the external storage, the read external storage permission here if you're accessing files from other apps. If you're, I don't know, like an audiobook app or say like a voice recorder app, and you just want to store those on external storage, but only you need to read them, then you don't need the permission. So I think with this kind of like rework of storage, I think there's definitely some give and take in the kind of permission, so you might not actually need it depending on your use case. So yeah, do you actually need the external storage permission? There's a nice little table in the documentation which I screenshotted, and there's a kind of little known API could get on the contacts to get the external files directory. You can use this, you might, if you were a game or that you were downloading, say like textures or some kind of large data files or something, you could quite happily use that to store it on the on external storage. You wouldn't use up the internal storage, and there's no actual permissions needed for that. You don't have to ask the user. And the nice thing about that is that it's removed and cleared up for you if your app's uninstalled. So that's, you may or may not be aware of that API. As I said, you have to use the media store going forward to read-write files to external storage. But actually, you only need the permission when you're accessing other apps' files, which is, I think that's pretty neat. However, if you're accessing files that don't fit into that media kind of those media buckets, you have to use a storage access framework, and that's effectively the system file picker where the user picks that directory or file. So for some people, for some of us here, that's going to be big changes to the way we do stuff. And so because of that, again, I think it's another thing of evidence of Google caring about not wanting to break our current apps. You can just quite easily just add this manifest flag. If you don't want to deal with it yet, you want to put your head in the sand, and that's fair enough. It could be, it could be a lot of work for some of us. But the warning here is, and I'll just kind of highlight this, this is coming. So this is the time to card this up in your backlogs, is to think about working on this, because in the next version of Android, this is going to be this is the way to do it. Independent of your target SDK, if you're running on Android R, you're going to have to deal with this. So yeah, this is the stopgap until we get there. But yeah, the sort of the clock's ticking sort of thing. Connectivity restrictions. So it's not just external storage that gets restrictions. There's, I think, without repeating myself too much, Chet mentioned this earlier. And yeah, you can't programmatically change like things like the Wi-Fi anymore, which is a real shame. Like years ago, I worked on an app that was a Wi-Fi finder app. It was an agency at the time, and we were building like an iOS version and an Android version. It was always a great one-up Android had over iOS, because you could, programmatically add Wi-Fi connections to the device and automatically connect. And so we could do much more than the iOS app. It was great. Can't do that anymore going forward from Q, as things like the Wi-Fi manager set Wi-Fi enabled we can't do. And this maybe only affect a subset of apps, but it's worth noting that the little asterisk there is, system apps and, device policy admin apps still have access to this kind of stuff, but regular kind of apps in the Play Store won't. You can get around this if you need to, and you might need to do this if you're, say, onboarding a IoT type device, and you're going through the wizard. You can use the Wi-Fi manager, add network suggestions, and then you listen for a broadcast. So there is ways around it. Although I know a few people who have tried this and it hasn't kind of worked. They're not getting those broadcasts back. So be interested afterwards if anyone's used this API and had success with it. Yeah, I'd like to hear your stories. But the way around this, or the kind of proper way of doing this now, is you're giving the user more control. You access the settings panel via an intent. Super easy to do, but the point is the user's making that choice. There is apparently an AndroidX wrapper coming. Not that this would be particularly hard to do. I mean, if it's running on Q, you launch an intent to the settings panel. If not, you either do it yourself or you open the settings app. But it's nice to know that that's coming. Incidentally, there's panels for internet connectivity, which is this one, Wi-Fi, NFC, and volume. And I wonder if more will be added in later releases, so to really cut down on our ability as apps developers to modify any of the settings and to bring the user into the equation and get them to sort of do it. That's the kind of restrictions on connectivity. The hardware IDs and things have been, this is like the end of the kind of line. This has been coming the last couple of Android releases. We've seen a restriction. Device ID now gives you a different ID per user signing key, sorry, per app signing key. That's different now, different between apps. And we've seen like things like the device serial number. It used to be a field on the build file, and it was moved to a method where you had to have like read phone state permission. Now we're sort of end of the line where those we don't have access to these anymore. So access to these, this is all to do with like tracking users and stuff. So if you are accessing these fields, these methods, you're not going to be able to do it going forward in Android Q. Again, there's another caveat on this. Device policy, device admin apps have some access to these. And something I only learned about sort of research in this talk, there's something called a special carrier permission, which carriers can apply for their apps, which I kind of would make sense for their access to the IAM number. But for most of us, will not have access to this anymore. So it now requires read privileged phone state. And for anyone who's familiar with the kind of privileged keyword in permissions, that's system only. So you won't get that. So if you target Q, try and access either of these, you'll get a security exception. Standard stuff. If you don't have the permission, if it's not granted, you would get an exception. If you're targeting less than Q, you'll get null or placeholder data back. That's if you have the read phone state permission. So it really is affecting all apps. So again, if you're using these IDs for anything, and particularly if you're using like an ad library or an analytics library, they could be accessing this data. Yeah, we knew this was coming if you look at the trend from the last couple of versions of Android. But yeah, we can't access that anymore, which I think is a good thing from a user point of view. But we need to rework this. And there, there's tons more stuff to talk about from a security point of view, and there's only so many minutes in this talk. But I wanted to sort of highlight a couple of the miscellaneous things that I found. One sort of nicety is that now TLS 1.3 is supported by default. And this is quite nice. That never kind of happens or it feels like it never happens when you talk about security. Something is stronger and faster. That almost never happens. So that's nice, nice touch. There's a couple of like low-level things. If you're doing stuff with the SSL engine like to do the way that the TLS 1.3 is different. You'll get some slightly different exceptions called. So if you're doing stuff and you're catching specific, I'm not sure why you'd want to do this if you're setting, I don't know, but there's a couple of different exceptions called in different places now. And also if obviously your, not necessarily obviously, sorry, but your API that you're calling will need to support TLS 1.3 as well. If it doesn't for some reason, you need to sort of force Android not to use that. You could do it by these two ways. You can set the enabled protocols, or you can set it specifically to get that sort of instance. I wouldn't necessarily recommend doing that. This is more of like just a stopgap if it's not working for you. It's not hard to get your server upgraded and supporting the latest version. And another thing on this kind of subject, if you're using a HTTPS URL connection, which probably most of us aren't, probably most of us are using OK HTTP, and we never think about this class or this kind of thing. But it's important if you're using an SDK that accesses the network, because they might be. The only time I've used HTTPS URL connection is when I've written an SDK and I don't want to add additional dependency to the OK HTTP library. Even though it's small, you want to keep your SDK as small as possible. If you're doing something like this, where you're calling the null, setting null to the SSL socket factory, previously that just would set up the default setup. That now throws, it's weird that it did that, if I'm honest. Now that throws an illegal argument exception, because it's weird setting null to the factory. There's actually a method called set default socket factory which you should use instead. And I just mention this because it's the kind of thing which you need to run and test for if you're using like an SDK. Like an analytics library is probably a good example where it's using network access, and it might be doing that, so worth checking for that. There's a slightly stronger way of running your apps by running the code embedded. So typically when you install an app, it would uncompress the DEX code onto the device. There's a chance that an attacker could compromise that and edit the decompressed DEX code. And if that's a concern to you, which it may be to some of you, you can now use this use embedded DEX true flag in the application object to enable this new feature. There's sort of the caveat with this is because it's embedded, you can't use compression on it, because it needs to be already uncompressed. So you're probably going to end up with a larger APK file. And there's this kind of thing in the documentation which says may have reduced performance. So it's one of those things which I can imagine this thing being flagged now on security pen test reports that you need to do it just because it's a new feature. But it's the kind of thing which I would recommend testing your app out, seeing how it runs if you notice any degraded performance. And there's also, so to make sure you don't compress the DEX, there's a Gradle option to do that. So you have to use those in combination. The non-SDK interfaces was kind of talked about a little bit this morning. I think in general, if you're using this, it's kind of wrong. Non-SDK interfaces, anytime you try and access a field or a private method or whatever, if you're using reflection, you've written that horrible reflection code or using JNI, we know when we've done it. Maybe we've all had to do it at some point. I know I have, and you kind of know that it could go wrong at some time. This is, it's going to start to go wrong very soon. There's more restrictions in Android Q. Actually, also some things that were restricted in Android P have been whitelisted. But in general, if you go to that link, there's a bunch of all the new restrictions. In fact, there's just too many to sort of really comprehend, I think, which is where having the strict mode option to detect non-SDK API usage is really useful. Hopefully, most of you use strict mode for network access on the main thread, database access on the main thread, that kind of thing. So I would definitely recommend enabling this on your debug builds, so you can catch this early and then kind because it could be libraries they're using as well. I've definitely seen this. I've run it on a couple of the apps that I helped build, and it was like libraries that were accessing private fields and things like that, which I wasn't aware they were doing. But, you just use this library for something, and that's the kind of thing which could trip you up and start erroring and failing kind of down the line. So, yeah, I'd recommend putting that strict mode option on. And then the last couple of miscellaneous ones. Background activity starts, another thing that's been blocked. Like, for example, if you had an intent service that downloaded a file, and then when that was finished, it fired up the viewer for that file. You can't do that anymore. The recommended way around that is to fire a notification. The user can then, the common theme, the user has to interact to choose to press that and then launch that sort of file, launch the activity. The clipboard's another one of those kind of Wild West kind of areas which has finally been plugged in Android Q. Previously, any app can just register for, it's not like a dangerous permission or anything. Any app can just register to listen to clipboard changes and do it once with the data. Now, it's been restricted, so it's only the foreground, the app in focus, and the default method editor, so like input editor, so like the keyboard effectively. Only those two apps can have access to the clipboard, which I think is a huge thing. It's kind of one of those things probably not a lot of people can think about. And it'll probably this restriction will affect, obviously, any apps that are a clipboard manager or something like that. But it's a nice improvement in the system that we know anything we copy and paste is not going to be snooped or hoovered up by other apps. And just lastly on the slide, the system alert window permission, that's now kind of being completely denied by default on Android Q Go devices. And for those unfamiliar with Android Go is like, or Android Q Go edition is like, it's a version of Android that's sort of targeted to lower-end devices. And Google handle more of the heavy lifting around updates and things like that. It's a much more vanilla Android experience. And it's part of Google targeting and trying to get their services into developing countries. India is a great example because it's good. There's a good sort of Android Go penetration there. But what it means is because Google have more control there, they can do stuff like this and just stop supporting a permission like that. And I wonder if we'll see this in the next version of Android for just regular Android. The thing to mention on that is so if your app's using this permission and you're on and the device gets upgraded to Android Q, it'll still work. But if the app is uninstalled and reinstalled, you'll never get that permission again. So if you're using that, it's time to rethink the way of doing it. And part of this is security, part of it is memory. Actually, if you look at the documentation, it talks mainly about memory. But this permission has been associated with tap jacking and stuff like that. So it's good that it's going away, I think. But it's not all doom and gloom, not all restrictions. There is a new official encryption library we can use as developers on Android. And whilst there's been other encryption libraries and stuff, this is the first kind of like Android-specific one from Google. AndroidX Security. This was, for me personally, with my interest in security, I thought this was one of my favorite announcements, even if it was kind of slightly quiet at Google I/O. It's still in alpha at the moment, and the min SDK for this is 23, is Marshmallow. That's partially because it uses Tink, which is a cross-platform encryption library from Google under the hood, and it stores the key in the Android key store, and for that it needs min SDK 23, which may be too high a min for some of us. What I really like about this it's safe and easy to use. And I say that from someone who has battled through using things like the JavaX security libraries and Bouncy Castle. Things that, they're great, extremely powerful, extremely secure when you use them right, but very, very difficult to get into and to understand, and always felt very easy to make a mistake. Whereas this, there is one choice in algorithm, one choice in option, AES 256 GCM, and last time I checked, that was the de facto, the one to use. That's your only option here, which makes it very easy to set up. And I'll show you some code, and it's very simple. There are two implementations at the moment of two real features of this library, and I'm sure we'll see it grow. But at the moment, you have an encrypted file and encrypted shared preferences. The last one essential if we're going to then look up that in the map of values. So that will be the same each time, whereas the value is non-deterministic, and that will be different every time. So that's a key a difference between those, and that's why that's separated. Yeah. And if you look under the hood, and this is using Facebook's Stetho plugin, you can see the ciphertext, which is a lot better than the user's access token and their email address. When if you want to use this and you're looking at migrating your current shared preferences, you don't necessarily have to migrate everything to use encrypted shared preferences. You really only need the sensitive stuff. So, like I mentioned, access tokens, refresh tokens, email addresses, that kind of thing. Yeah, and you should definitely think about as well what happens if the decrypt fails. So this is a very simple API, but under the hood, the key store, Android key store, can be a bit unwieldy, and on certain devices where they've done weird stuff, which you don't know until you start using it. I've had people had issues on Huawei devices. I probably butchered that name, but on different manufacturers where they've done weird things, and for some reason you can't
store a new key, or when you try and get your key back that you've created, that it's just not there and you get a weird exception. So this sits on top, makes the API really easy, but you're not going to get away from those kind of weird issues on some devices. So you have to think code for the fact, what if the decrypt fails? For the most times I use this kind of thing, it's, I'm caching offline data for an app. Worst case scenario is that they have to re-auth. I can't get access to their auth token, the refresh token, so I have to prompt them to re-log in and just wipe that data. That obviously doesn't work if you're an offline password manager and you're storing all the encryption fails to decrypt a password database. Obviously that's not going to work, and I don't have a magic answer to how you solve that, but it's something you need to think about with what you're storing. And just lastly, I wanted to cover platform hardening. A shout out to this really detailed article, which is far too much and low level to talk about in a presentation. But I just wanted to shout out. It's worth reading if you're interested in that. There's some good stuff about how they've enhanced the memory sanitizers and how they're separating like hardware and software codecs. But yeah, I'll let you, as an exercise for you folks to go and read. The other thing I want to just cover in terms of the platform is Adiantum, which actually I've never heard said out loud, so I'm not sure if that's how you say it, but we'll see. This is a key one. So like a couple of versions of Android ago, Google had to backtrack where they were originally going to enforce disk encryption, but they had to back out because it slowed down devices too much, some devices, and that's because of its lack of AES hardware support. So this Adiantum being part of Android Q, it's part of the platform, means that lower-end devices like Go devices, smartwatches, and TVs should now be able to have file and disk encryption enabled by default. Again, it's not necessarily something we can use ourselves as app developers, but it makes the platform more secure. If people are more secure, more confident on the platform, it means maybe they'll spend more money. Maybe we can do more interesting applications because the platform's more secure. And I've also included mandatory, as every talk has to have a graph in. I've got that in there. So like just to literally wrap up, hopefully we're all, I know we're all super busy doing features, but hopefully I've covered a couple of things which, if you use things like location, the external storage and things like that, there are breaking changes coming, and we'll need to do some rework. But there's some cool stuff like AndroidX Security, which make our lives easier. If there's just one thing you take away from this talk, it's this checklist. It was a kind of basis for this talk, as well as being, it's the kind of thing that you should go through with your team and just go through, it's very clear on the key behavior change, the, how it's affecting your app, the mitigation strategy, and how to enable it, whether it's just targeting Android Q, whether it's all apps. Really useful. This is just a screenshot of it. There's a bunch more stuff, and well worth reviewing. So with that, thank you. I'll take questions outside, but feel free to email me or come up and say hi. I've travelled all the way from Bristol in the UK, so I work remotely, so I'm happy to chat to people face to face for a change. So come and say hey, ask me a question, or tweet me. Cool, thank you.